Hello everyone, today we'll talk about the solution to the problem minimum swaps to group all ones together 2. We are allowed, of course, to swap elements, and in that case we can essentially look at it in such a way that if we want a 1 at a given position and there is a 0 at that position, we can just swap that 0 with a 1 and that's it. In particular, since as a final result we want to group all the 1's together, so we want to have some block of 1's and some block of 0's in this circular array. We won't care about the fact that the array is circular at this point, since it's easy to just slightly modify the algorithm to work with that case in mind as well. And probably the most important observation to make sure that you actually can easily implement it, easily think about this problem, is that since the number of 1's doesn't change, the final array will consist of the block of 1's being of the size of the count of 1's in the original array, of course. So that block, we can immediately determine how big it's going to be. And of course, considering the array is circular, it might be wrap around the array, but it doesn't really matter in this case. And if we know exactly how big that block is, then the only thing that remains for us to say is how hard it is to create a block like this. Because in particular, we can, knowing how big that block is, for instance, if this is a block like this, we can try all the possibilities for where this block starts, because essentially the only possible results are an array that has this block of 1's within it. It can start at any position in the array. It can also, for instance, start here, of course. And if we can easily verify for every position what is the cost of making that block at this position, then we take the best of those, and this is our result. And the cost, well, for all the ones that are within this block at the beginning, we don't want to do anything with them. They are already okay, all the ones are indistinguishable, so we shouldn't really touch them. And of course we have to get all the ones inside it, get all the zeros out of it. So for every 0 that's within this block, there is some 1 outside this block, because remember, this block is of the appropriate size to hold exactly all the 1's. And we can just swap that 1 from outside the block with a 0 inside the block. So the number of steps required is just the number of zeros within this block. And the only thing that remains for us to calculate at this point is to check for every position, for every possible position of this block, what would the cost be, what the number of zeros, or equivalently the number of 1's within this block are. And we can do it by just calculating it for the first block manually. We still have to calculate even the size of this block by going through the array once. So we calculate manually the number of 1's in that first block. And now whenever we want to consider a different block, we might consider a block that's shifted to the right by 1 spot, and now this thing we subtract. So if it's a 1, then we've lost a 1. This thing we add, so if it's a 1, we've gained a 1. And now we have exactly the number of 1's within this shifted window. So this is a standard sliding window of a fixed width over the whole array. And of course we have to make sure that we consider those windows that go outside the array. So essentially either we just modulo, or we even can elongate this array with what happens at the beginning. We can just paste it there. And of course the code is very simple. We count all the 1's. This is the size of our sliding window. We count all the 1's in the first sliding window. And we remember the best sliding window for us. So we go for all possible starting positions, and those starting positions are, well, that's not starting position, those are the positions of the next element to add. So the next element to add, the first one is at position width of the sliding window. The last is at position number of elements plus width of the sliding window minus 1. So that would be the final element somewhere around here. And we just look at this element, and we here have modulo n to make sure that we look at the appropriate element in the circular array. If it's a 1, we add 1. And of course we have to drop the element on the left. It's just an element at position, the element we've added now, minus the width of the sliding window. If it's equal to 1, we subtract it. We see if it's the best that we've seen previously. So we compare it with all the best, we take the maximum. And at the end, to make sure that this sliding window of width 1's consists only of 1's, well, we have to swap all the zeros but we have all the ones that were there for free, so we just subtract the number of ones, and that is the final result.